Find the sum of the infinite geometric series. So here we have an infinite geometric series, and if we look at our summation notation, we know it's infinite based on the fact that there's an infinity symbol at the top right there. We have a nice, clean formula to use. I actually like this one a lot. So if you know it's an infinite geometric series, there's our equation or our formula we use to find the sum. Now the only thing that's going to be tricky about these to remember is sometimes an infinite geometric series has a sum and sometimes it does not. And it all depends on your common ratio. So if the absolute value of your ratio is less than 1, then a sum does exist and we can find it. If the absolute value of your ratio is greater than 1, then there is no sum, and we would have to write no sum. Now what's tricky about this is you can do the math in either case and get a number, but if the ratio is bigger than 1, a sum really doesn't exist, even though mathematically you can plug into the formula and get an answer. So we definitely need to make sure we pay attention to whether or not a sum actually exists. So that's our first check. We come to our example and we have to look at our ratio, which is going to be the number that has this exponent of I minus 1. So we do the absolute value of a negative 1/3, which is just 1/3. Is this less than 1? This is what we're checking. If it is, we can find the sum. And it is, so a sum exists for this first one. So in order to find the sum, we need our first term, and we need the ratio. Well, the ratio we just said was a negative 1/3. And the first term is always that number out front, so the first term is going to be a 2. So to find the sum, we just follow along with the formula, 2 divided by 1 minus a negative 1/3. Now it's going to be tempting to go to your calculators on these, but I want you to work with the fractions. It's going to give us a nice exact answer. So 2 divided by 1 minus the negative is 1 plus a third. And 1 plus a third, if we think about that just off to the side, we can go ahead and make this 3/3. So we have 4/3. So we have 2 divided by 4/3. Now can we leave an answer like that? No, we can't have fractions within fractions. So we want to go ahead, instead of dividing by fraction, we always flip the bottom and multiply. So 2/1 times 3/4. And we do see that we can do some reducing here. So we end up with a sum of 3/2. So that's how you find the sum of an infinite geometric series. Now if we look at this next example, we notice, okay, it's infinite, it's geometric. Looking at the rule, we can tell this is a geometric rule. So we have to find our R value, and we have to test, is the R value, the absolute value of the R value less than 1? So our common ratio is 4, so the absolute value of 4 actually is just a 4. And is this less than 1? And because it's not, that means that there is no sum, and we have to actually write no sum. Don't do the math, because you can get a number back and tell me that this is what the sum is, but if that ratio is bigger than 1, there actually is not a sum. So test your ratio to see if a sum exists. If there is, use the formula to find it. If not, we just write no sum.